Very good morning, everybody. Hope it is audible for everybody.
Yeah.
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 Yes. So I extend my warm welcome to all the participants for today's exciting webinar. It's on a complete life cycle of a fuel cell technology and its application in automotive industry. And let me give a small introduction about EVOKE, what we are trying to do here. Maybe it's the expanded form is like the electric vehicle open knowledge for everyone. It is not just with the electric vehicle, it is like a complete, it will cover a complete perspective of clean and green energy from automotive industry. And also like we can also call it as a forum where we are creating awareness and we are trying to bring in the latest trends of sustainable and eco-friendly solutions from automotive domain. It is for both academia as well as industry people. So we welcome people from everybody, as well as even as participants, as speakers. We have a plan of conducting a series of interesting topics throughout the year. And also I would request everybody to join continuously for all the sessions and get benefited. And I would like to welcome our EV and Automotive Committee Chair, Henry Joshua, to the session. Hi, Henry.
Hi, Kalai. Thank you, everyone. Thanks, everyone, for joining.
Yeah. So about Henry, he has almost 2 decades of experience in automotive industry, and he has seen a transformation of the industry from mechanical to electrical phase, complete transformation. And he is also a founder of Dot Sign, a digital organization, and also like he is now the head of business development in analog devices. So, Henry, would you like to say a few words before we start the session?
Sure. First of all, thanks everyone for joining. Today we will be focusing on fuel cell, and as you know, fuel cell is one mix of the green mobility. Yeah, so there are many different options. It's not just all about electric vehicles. In India, electric vehicles is a very fast growing topic. Not only topic, but you will see them on the roads. Last year, as of last year, there were about 1.5% only that was sold. However, this 1.5% is a big growth from the year before. So year after year, there's been a big growth. What big growth also means opportunities to learn, opportunities to work. And I think we are all in the right phase of the wave that's going up. So I think your interest and your curiosity will be rewarded soon. So again, thanks for joining. Hopefully you all benefit from the sessions. If there are Q&As, we will also address this towards the end. Thank you.
Thank you, Henry. I would like to give a warm welcome to our honorable speaker today, Dr. Prabhu. About Dr. Prabhu, he is a professional in mechanical engineering, and he is specialized in thermal management of batteries and fuel cells, and as well as computational fluid dynamics. He holds his master's degree in internal combustion engineering and PhD in mechanical engineering. Currently, he is serving as an assistant professor at Amrita Vishwa Vaidyapeetham. Also, he is a project director at Greenam Technos Private Limited, and he is guiding the startup team to develop products related to batteries and fuel cells, all green technology. And coming back to the topic, so it's all about fuel cell technology, right? Why we need fuel cell and what are the future trends of it, and how will it help in achieving zero emissions and eco-friendly sustainable solutions. So that is something maybe Prabhu will be able to give a clear picture on it. Yeah, with all these interesting questions in mind, I hand over the session to Dr. Prabhu. Yes, over to you, Prabhu.
Yeah. Thank you, Kale. Thank you for such a nice introduction. And thank you, Henry. So thank you both of you guys for giving me an opportunity to share my knowledge, what I learned in fuel cells and batteries to this forum. I think it will be of good use to the people here. I will just share my PPT. So is that visible?
Yes.
Yeah. Okay. Good morning, everyone. To all the listeners who are interested and excited to know about the fuel cell technology and what it is and how it is going to impact and how big is this hydrogen economy. So I'm going to take you through a macro level. I'm going to introduce you to a system level, to the user level, and I think there will be a lot of data, numbers, and pictures. If it is overwhelming, sorry for that. Okay, so please enjoy this session. Okay, the content of the topic is the first I wanted to go through the fuel cell evolution. What is fuel cell? How it produces energy, and how the performance is compared with the other energy resources. If you're having a gasoline car, if you wanted to tomorrow go and replace with the hydrogen fuel cell, how much it costs? So how much it gives per liter? How much kilometers it gives per liter? So we'll see those numbers. So that will give you an interesting point. And then how it is integrated with the automotive and stationary application. So fuel cells means it is not only for automotive applications. So it can be used for the stationary applications also. What are the different kinds of efficiencies it holds? We will see that. And the last thing is, okay, we talk about technologies, we talk about integration. So how it impacts our economy, or technology should impact an economy. Otherwise, there is no use of technology, right? Okay, we will see that. So these are the contents which I'm going to take you through today. Okay, so bumper. So I just came up with this news when I was reading the article like 2-3 days back. So it says global investment jumped 17% and it is $1 trillion in 2023. So a technology to move forward to become an economy, what is needed is two things. One is government-driven policies. Second thing, the policies-driven investment. Okay, without these two things, the technology cannot mature and cannot reach everyone. So if you see the sector-wise, so okay, $1.8 trillion. How does the sector-wise it split it? And you can see the electrified transport. I will just concentrate on two things: electrified transport and hydrogen. So you can see the green bar here, right? So the green bar here had grown from 2015. It was a very small, and it had grown like anything till 2023. That we are seeing it rarely, right? So there are a lot of investments going on in EV sector. So two-wheelers, three-wheelers, trucks. Okay, so there's a huge investment is driven in the EV sector. And hydrogen economy is still, you can see a small purple line. There's a small line. Thing is, hydrogen side is evolving. Still, the governments are forming the policies how to implement it. Okay, and last 2-3 years, the investment in hydrogen economy had tripled. Okay, even though it is small, the rate at which it is increasing is a higher. And how our country, so how India is placed in the top 10 economy. So we are placed at the bottom is 31.4 billion. Okay, still there are a lot of investments coming in. When it compared to China, it is the biggest investor in this domain. So in 2022, when coupling with all other countries, China was the dominant leader in investment. Of this year, 2023, so adding up the other countries' investment is more than the China now. So thing is, India is looking forward. We are at 9, maybe in 2025, 2030. So we will be moving up ahead in this economy, which we are having a huge potential here, which will make us to move ahead with these investments. Okay, so now I just gave you an idea why you need to know the hydrogen economy. This is an evolving economy which everyone will be interested in. Okay, that is a global level. What comes to the national level? What Indian government is having a mission towards hydrogen economy? So it's looking for at least 5 million metric tons of green hydrogen with an installed electrolyzer capacity till 100 gigawatt, and which can reduce the emissions by 50 million metric tons of CO2, an investment of $100 billion. So this is a mission which is set by this, which is set by the government, and this mission was released last year. And they are also have categorized the projects. Okay, they have a blue sky grant project. They have a 3 category of projects which target for 0 to 5 years, 10 to 15 years, and 30 years. The government had clearly laid a roadmap for the hydrogen economy. Okay, so what is hydrogen? So we are talking about hydrogen a lot. So hydrogen is available everywhere, but not as a gas. So it has to be broken down from any components available from any hydrocarbons. So the hydrogen means is a generation of water. Okay, so this is hydrogen. So how can I? Okay, hydrogen is not a gas and it is a colorless thing, right? So why you guys are calling it as gray, blue, turquoise, and green hydrogen? So I'm start people might think, oh, what is they are talking about different colors? Does that mean the gas has some color? No, the colors differentiate with respect to the production methods of each hydrogen. So gray hydrogen talks about steam reforming of methane gas, and your emissions will be a CO2. And blue hydrogen talks about again a steam reforming, the emission which is a CO2 is captured. So nowadays you guys might be hearing about carbon capture systems. People are investing in carbon capture systems. So you wanted to capture the CO2 which is coming out of this reaction, but you can't capture 100%. Still, there will be a leakage of CO2 where around 10 to 20% will be leaked. That is a blue hydrogen. And then turquoise hydrogen. So turquoise hydrogen is about breaking the bonds of methane into hydrogen and a solid carbon. So that is still in a research area. And the last thing is green hydrogen. So, okay, green hydrogen means what? So it is a renewable energy. So you need some energy to do this process, steam reforming or electrolysis. Electrolysis is nothing but breaking down H2O into hydrogen and oxygen. Okay, you need energy to do this, right? So where does the energy come from? Electricity. So electricity comes from thermal power plants. Okay, if I am using the electricity from a solar or a wind power or any renewable structure, then I call it as green hydrogen. Okay, so currently you can see there are many companies are planning for protection. So most people talk about blue and green hydrogen, which can reduce the carbon imprints. Okay, so that's the reason there is a different color in terms of hydrogen production. Okay, what is an economy? So economy is something where you produce, you store, you sell and recycle, right? So that's an economy. The same economy can be created using a hydrogen. So I can produce hydrogen, I can transform hydrogen into some other synthetic fuels or green ammonia. I can transport it from one place to the another place by different modes of transport, pipeline, trucks, using ships, and I can use it in a different end user. I can supply it to a different end user. The different end users are nothing but steel industry, chemical industry, refineries. Again, in transport sector, it can be shipping, aviation, automotive. Okay, so the economy is circular. You can manufacture, you can produce hydrogen, you can transform it, you can transport, and for the end use. And it bears cost, right? So from production till it reaches the end user, there is a cost is incurred in each and every stage. Okay, again, this is a roadmap. So I gave you the economy. So based on this economy, our government came up with a roadmap. So roadmap that applies the immediate need for the industry. So they are looking the transport sector as a future potential for 10 to 15 years down the line. Okay, so currently they are setting up the manufacturing units for the hydrogen production. You need electrolyzers. The government is setting up the stage by stage process. You put the manufacturing plant, produce the hydrogen at a cheaper cost so that it can be transported to the next level of growth. So you can see the different applications about government at ammonia production, methanol production, hydrogen refineries. Why a government is targeting these areas? Because we have fertilizer industry, cement industry, right? So there are about 24% of greenhouse gases are produced from that. Okay, to decarbonize this sectors, hydrogen is introduced. So hydrogen production, ammonia is produced from hydrogen. Ammonia can be a carrier of hydrogen. Okay, so all this process, hydrogen can be involved. So to reduce the greenhouse gases, our government intention is to first use the hydrogen production in these plants. Second thing is building. Buildings is if you have a city gas network, the hydrogen can be blended with the gases to increase its efficiency, and also the transport. Transport is the last sector which government is seeing as a future potential in using the different fuel cells in automobile or commercial vehicle applications. Next, we talk about fuel cell. Okay, we discussed about hydrogen. So hydrogen is produced, and there are different colors of hydrogen. Okay, what is a fuel cell? So, like a battery is producing a current, we know there is a reaction happens. Similar way, the electricity is produced from a reaction, which the fuel cell has an anode, a cathode, an electrolyte in between. So we are going to see a different type of fuel cells which will have different electrolyte membrane, okay, different catalyst along the anode or a cathode side. So the hydrogen is fed up from the anode side. So once it comes in, the hydrogen breaks up into protons and electrons, and protons passes through the electrolyte, the H plus, and the electrons travel and produces a current. And then it comes here on the cathode side and it reacts with O2, and the output, the exhaust emission is nothing but water. Okay, so what happens? You have a fuel cell. So seeing it will be like it will be like less than 1 centimeter. All these units comprised together. It will be very, very thin. Anyway, the description here shows a bigger unit, but each cell is very, very thin, which has an anode, which has a cathode. Hydrogen comes in, breaks down into protons and electrons. The protons passes through the electrolyte, and the electrons passes through a current. And then your exhaust will be water. So this is the reaction happens in a fuel cell. Okay, so this reaction happens. So how does the current profile look like? What is the voltage? Okay, let me show, give me the numbers. You can ask what is the voltage and the current, how it shows up. So this is called as a polarization curve or a voltage current density curve. So each cell has a capability. So one unit is one cell has a capability of maximum 1.2 volt. And your current density varies with respect to the area exposed for the reaction. Okay, so there is a curve which shows a behavior where there is a sudden dip at the initial and at the end. So this dip is due to some losses. So there are some losses, right? Any system you have, you want to produce energy, there will be some losses. So here there is an activation loss, then there is a ohmic resistance loss, and there is a mass concentration loss. So I'm not going into detail. So why this curve looks like this? This is your output from your fuel cell. This curve looks like this because there are 3 different losses it incurs when the process is happening. So if you relate to the batteries, if you have a cells, lithium-ion cells, each cell is 3.2 volt nominal voltage. So you can, if you have an idea on the battery side, you can relate to the voltage and the current capacity of the battery cell. Okay, then, okay, so we saw fuel cell and fuel cell works, and fuel cell is giving a output of voltage and a current. How it, what is the, how long it took for a fuel cell to get developed? So from the day a person begins it innovation. So 1800s. So 1800s, fuel cell is not that, but they produced hydrogen. So the hydrogen is produced. They are using a hydrogen for IC engines, to power IC engines in 1806 and 1860, and they developed 3 vehicle Hippomobile in 1860. And 1889, the first hydrogen fuel cell, the idea was conceived. I forgot the name. Let me remember it. Ludwig Mann. Sorry for that. There are a lot of names there. So Ludwig Mann in the fuel cell term in 1889. And during the development, there is a gasoline. So gasoline came in and overtook the hydrogen, and gasoline was dominating a few years. And in 1930, the first hydrogen truck emerges. Again, this first hydrogen truck is not with the fuel cell. They have the reformer. Okay, they convert into hydrogen. So electrolysis process, they have a reformer in the vehicle, convert that into hydrogen, use that hydrogen in ICU. In 1941, Russia converts 200 gasoline powered truck to hydrogen truck. And in 1960, GE produced the first fuel cell power system for NASA. Still, this electrolyzer is used for generating water for the space crew members. So in 1966, again, GM came with a fuel electric vehicle. And then 80, it is tried, it is used in submarines where they're able to escape from the enemy radar for 3 weeks, submerging in. So you're replacing an IC engine or something, so there is a less noise, less mechanical components. So that will help you to navigate silently. And 88 itself, Iceland announces a hydrogen economy. And 99, the first commercial station opened in Germany. And 2000s where a lot of development happened in modernizing the hydrogen fuel cell. So I will show you the cars which has been launched. So 2014, Mirai was launched, Toyota Mirai, then the Hyundai came in, then BMW came in. So every company started launching the fuel cell cars from around 2014 till now. And still there are a lot of development going on in automobile sector. And I talked about fuel cells. Okay, the fuel cell means there are only one fuel cell? No, there are different kinds of fuel cell based on different chemistries. Alkaline fuel cell, AFC, polymer electrolyte membrane fuel cell, direct methanol fuel cell, phosphoric acid fuel cell, solid oxide fuel cells. Out of this, there are 3 fuel cells which plays a major role. They are, the second one, PEMFC, DMFC, SOFC. So they have a good market capitalization in different regions or domains. So PEMFC has some advantage, DMFC has some advantage, and SOFC has some advantage. So PEMFC uses hydrogen as a fuel. Direct methanol fuel cell uses methanol as a fuel. SOFC uses natural gas, biogas. So it uses gases directly. And the operating temperature is very high for SOFC, and PEMFC and DMFC is 60 to 90 degrees centigrade. Again, you compare it with the batteries. So what is the operating temperature? So thermal management of the batteries is very important. Similarly, the thermal management of the fuel cells is also important to make it work efficiently at that region. So the takeaway is PMFC, DMFC, and SOFC. So what are the advantages with these fuel cells? So DMFC is low startup time, high energy density, and it is smaller capacity, less than 1 kilowatt. So it's like it's like a power bank you have, right? So smaller size of accessories you wanted to power up, you can use DMFC. And it doesn't have any hazard like the flammability which hydrogen has. Second is PEMFC. PEMFC is mostly used in automobile industries and also low-scale power generation units. And SOFC. SOFC is for higher capacities, greater than 10 kilowatt, 50 kilowatt units. So they will come up with a very big power capacity, and each one of them have a different efficiency ranges also. DMFC has around 30% of efficient, and PMFC has around 50 to 60%, and SOFC also has a 60%. But when it coupled with the cogeneration plants, the heat, using the heat, you want to recover the heat and use it for some other purpose, then the SOFC power plant efficiencies can go up to 85%. Okay, so I showed you the different types of fuel cells, right? So how the market share is all about. So PMFC is more than 60%. PMFC is holds a big market share, and followed by SOFC, solid oxide fuel cells, and molten carbonate fuel cell, phosphoric acid fuel cell, and alkaline fuel cells. And others are very small. So, okay, so there are few manufacturers. You can just go and type and find the names for your interest. I put Ballard, Bloom Energy, might appear, Doosan Fuel Cell Energy, Intelligent Energy. So you can go in and see where these fuel cells are used, the fuel cells which are produced by these companies. That gives you a good idea. Like drones, the Doosan Fuel Cell and Intelligent Energy, they use fuel cell for drones. So if you have a larger drone, so with IC engines, you can replace it with the fuel cell easily. And how does the fuel hydrogen fare with other fuels? Okay, liquid hydrogen, hydrogen gas. So each column describes a characteristics of property of those fuels. So I wanted to highlight only the hydrogen, and you can compare this hydrogen with gasoline or natural gas. So the gravimetric density, the mass density is very high for the liquid hydrogen. Whereas the energy density for a gas, hydrogen is very low. If you compress the liquid hydrogen, sorry, gaseous hydrogen, so your volumetric efficiency is going to increase and your energy per volume delivery will be higher. So that's why the liquid hydrogen has 10 and hydrogen gas is 0.013. But still, when you compare to the other fuels, so the energy density with respect to the volume is less. With respect to the mass, it is very, very high, 3 times the gasoline and the natural gas. So I just want to show you how much the calorific value you call in terms of gasoline fuel, other fuel. So heat value you have in burning this hydrogen. So this much amount of joules of energy can be released by burning 1 kg of hydrogen. Okay, we compared it with fuels. Why can't we compare it with the renewable energy? So why we need a fuel cell? Already there are wind power, solar power exist. Why do you need a fuel cell? How it is compared? How it is cost-wise? How it fares? Let's see. So just concentrate on here the fuel cell, the right side. Okay, so you have a blue one is a capital cost per unit, and then you have a replacement cost per unit. So two things are I'm trying to show here. So the fuel cell has this is compared with the 1 kilowatt production. If there is a 1 kilowatt produced from a fuel cell or a wind turbine photovoltaic, we are fixing the amount of power output and trying to compare among the different renewable energies. So the fuel cell cost, these are in dollars. So fuel cell cost around $20,000. And when you compare it to wind and photovoltaic, it is thrice more than that. So 4 times the cost of the wind turbine photovoltaic capital cost. And again, what is the life of them? So, okay, wind turbine photovoltaic comes around 10 years of lifetime. You can see in the left-hand side picture. 20 years of lifetime, the gray ones, wind turbine photovoltaic. Whereas the fuel cell, you have only 5 years of lifetime. And then the efficiency of the fuel cell, as I mentioned, it's around 50%. The efficiency of photovoltaic and wind turbine is around 6 to what is that? I forgot to put this. So it's around 10% to 15%. It's very, very small. So these are the differences how the fuel cell in cost-wise fares with wind turbine and photovoltaic sunroofs. So we saw individually, so wind turbine, photovoltaic, so all have a different capital cost, maintenance cost, operating cost. It has a different efficiency. So why can't we couple it together? So each one of them has some disadvantages also, right? So why can't we couple it together and make a single system? So why they can complement each other? If you have a daytime, wind is there, sun is there out, and your load, the demand side is very less, I can use those energy to produce hydrogen using an electrolyzer and then store that hydrogen and then use the hydrogen later whenever the demand is more during the night time. Okay, so in that way, you are not losing the energy in the grid rather than storing that energy by means of producing hydrogen and using that hydrogen later to produce energy. Okay, so this can be an apt solution where the renewables and the hydrogen fuel cell can couple. So this I am talking about a stationary plant kind of a thing where this can be complemented. So it is not only FMFC fuel cell can be used, any other fuel cell can be added. Again here, instead of a lead acid battery, the battery technology is, these two technologies are moving ahead, right? Fuel cell and battery technology. We are talking about lithium ion, we are talking about lithium ferrous phosphate, and now everyone is talking about sodium ion. So okay, that technology is going to change, but the coupling of this unit will give you an increased efficiency of utilization of a power. Then I want to talk about safety. Okay, we produced hydrogen and we are mentioned about usage of hydrogen. How can I store and transport it without any hazards? There are different means of storing the hydrogen and transporting the hydrogen. So compressed hydrogen, you can compress the hydrogen to around 700 bars in a tank and store it. So in a tank, then the tank should be so much strong, and there is a different categories of tanks available. So hydrogen is more corrosive, so it can corrode the materials inside the tank. So there are different types of tanks which has been prescribed for storage of hydrogen for different purposes. They're talking about type 1 tank, which is a metal tank, which is used for a stationary storage purposes. And they can bury inside the ground also. Type 2 is a metal tank coated with the liner. Type 3 is tank coated with aluminum liner, and the type 4 is the tank coated with some plastic liner, and the tank is made up of a carbon composite. So each type has a categorization, and if you move from type 1, type 2, type 3, type 4, the type 4 is 30 to 40% of less weight when compared to the type 1 and 2. Because type 4 is used for transportation. So in automobile, cars currently running with the hydrogen fuel cells will have type 4 kind of a tank where they can store the hydrogen. Second thing is liquid hydrogen. Liquid hydrogen requires so much energy to liquefy the hydrogen and store it. And even though you store the hydrogen in a tank, you have to maintain the temperature of 20 Kelvin, which consumes a more amount of energy and increases the cost of storing and transportation. Third part is cryocompressed hydrogen. The cryocompressed hydrogen is about using compressing the hydrogen to such a volumetric to increase the volumetric range of the hydrogen. Means you compress it to 200 to 500 bars and reduce it to the cryogenic temperature and store it in a tank. Again, this is also a energy consumable process. The last part is material-based hydrogen. So material-based hydrogen is to use a chemical absorption process where there are some metal hydrates which can absorb the hydrogen, and then by again a chemical process, it can, you wanted to extract the hydrogen, it can be done. So metal hydrate is one. So these, again, this is a big research area everyone is working on, the safety storage of hydrogen. Okay, fuel cell integration. So how about the globally and domestically the integration is happening at this point of time? So let me just show you the cars, which is of a hydrogen fuel cell. Till now, you might have seen your car, like your car, you have a specification pamphlets and saw what is the acceleration, what is the engine power, what is the top speed your engine can make, and what's the range of the thing. So now the similar thing we experience with the fuel cell. Again, fuel cell power for Hyundai, Toyota Mirai, Hyundai iX fuel cell, and Honda. So each one has around 100 kilowatt of fuel cells. Okay, which the engine power is around 100 kilowatt to 130 kilowatt. And when one charge, Toyota Mirai can go up to 500 miles. So one charge means 5 kilogram of hydrogen. So I pump in 5 kilogram of hydrogen in the tank, and I can drive the car for 400 to 500 miles. So now you can, if you have an EV, electric car or electric vehicle, you can compare it with this. So if you do a one charge, so how long you can travel? But one charge might take 20 minutes, 30 minutes, 40 minutes. But here you have to just take 5 minutes to put in the gas. But you still have a question, how many hydrogen filling stations are there? It is less. It will evolve slowly. Next is what is happening in our country. So people are launching vehicles, or people are developing vehicles. Yeah. So Tata Starburst fuel cells, already it has been delivered to IOCL, I think in last September. I don't remember the exact date. But Tata Starburst has been delivered with the fuel cell, has a capacity of 85 kilowatt. And Ashok Leyland is still working on the truck for with fuel cell at an 80 kilowatt. It has a battery pack of 55 kilowatt hour with the motors and the wheels. So these are the two products, or these are the two things which is currently happening. Maybe I am not aware of many things, but as far as the hydrogen fuel cell is concerned, these are the two vehicles which is in production, and it is one is on delivery. And we will see about small things about stationary energy storage. So I mentioned about dimethanol fuel cells, right? So dimethanol fuel, you can see small packet like this, right? Small box like a power bank or a Wi-Fi router kind of thing. So this is a small fuel cell, a hand-carried fuel cell, which uses dimethanol as a fuel. So they will have cartridges of dimethanol. So you can put the cartridge into it, and there is a membrane here, it will generate power. So mostly defense purpose, where people needed energy or for the accessories, whatever they are carrying, they can use this kind of a fuel cell, which is very handy. And they can also have a larger capacity, which can be used as a power bank. As I said, you can just generate the power whenever you need and use it for the devices you have. Next thing is solid oxide fuel cell. Again, stationary, Bosch, Toshiba, and Mitsubishi. So they are having the SOC power plant, which is of a very high capacity. So they are using this power plants for energy generation in industries. You can replace this with diesel generators, and you can have your own generators with SOFC fuel cell chemistry. So these are the devices available across. Okay, what about the future? So these are what currently available, right? Cars, stationary devices. What people are working for? Like, people will have a vision. There are a lot of startups around the world which are working on. So yes, there is one startup like Zero Avia. they are developing a hydrogen electric engine to fly. So they did a pilot test, and they will be doing the test for next for a year. I think by next year they will be launching this fuel cell engine. And there's another company called Power Up Energy Technologies, and they have this small pack. You can see the small pack, right? White color. This is 1 kilowatt portable hydrogen. They have 1, 800, 500. And you can couple it with your solar panels and wind energy and generate energy and store. So mostly they use for the boats and during traveling, you can use the fuel cells to power up your accessories. Okay, not only that, can you imagine driving a cycle with a fuel cell? Yes, it is possible. People had already developed, and some models are available in the market. You have a water bottle, right? So the tank or the hydrogen holder will be like a water bottle. So you can just fill it in the hydrogen, and then you can put this in the uh, frame of the cycle, and there is a fuel cell inside, and it will drive the cycle. And people are using for hydrogen forklift, hydrogen UGVs, hydrogen drones, keeping a fuel cell. Here you can see the drone, which I am, there is a small cylinder under it. So that small cylinder is nothing but the hydrogen cylinder, and the fuel cell is there. Instead of a battery or IC engine, you can replace it with a fuel cell. And the cars, local urban mobility, a small car. This car uses 1 kilowatt fuel cell only. So 1 kilowatt fuel cell. There's another company startup, Ecogenium, who are working in the Hydrax. The name is Hydrax project, where they are trying to develop the hydrogen fuel cell for urban mobility. So you can see that many people or many startups have a very great vision on the application side. So overall, if you see, there are 3 regions which we saw, 3 opportunities. So one is hydrogen generation. Second thing is hydrogen storage and transport. The third thing is hydrogen application. So these 3 areas are open for opportunities and development. And a lot of innovation should be made on how can we reduce the cost, how can we transport it more safely, and how can we use the hydrogen efficiently. So these 3 parameters should be taken care of. Hydrogen production, what all can be done? Process efficiency can be improved. Green hydrogen, okay, so amount of electricity consumed per kilogram of hydrogen produced, and protection of that electricity using a solar or wind power. Cost-effective solution is needed. Number of generation units. Okay, so the raw materials, the catalyst involved in the reaction, they're using platinum, iridium, graphites. Okay, the different types of electrolytes, the cost of those raw materials. So by reducing all this, you can produce a cheaper hydrogen. And then producing a safer transport facility, a compressed nitrogen with a safer container at a lower cost. Okay, and then that will save you the transportation cost, a capital cost maybe. Then usage of hydrogen in vehicles, cars. We talk about automobiles. We talk about passenger cars to commercial vehicles. So which will be more efficient? How will we drive it efficiently? That can be compared. And a small bar chart again for a comparison purpose. So there is centralized methane. So I mentioned about 2 processes, right? The steam reforming of methane gas and electrolysis. The centralized or decentralized means you have a capacity wise. If you have a huge capacity plant where you are producing hydrogen and transporting hydrogen, or your decentralized plant is having a small capacity plants at the fuel. If you have a fueling station, you have a plant there itself of a lower capacity. So that is a decentralized plant. Okay, so by saying this, you can immediately understand if I produce in a larger number, I can get the cost cheaper rather than having a higher capital cost for a decentralized unit. So centralized units will give you a less cost. You know how much cost? It says dollars per kilogram. Let me count the number and say you. So by centralized electrolysis, it cost. You can see the feed cost is higher. It cost around $3 per kg. Whereas centralized methane, it cost around $1 per kg. Okay. And then you come for the transportation purpose. So transportation purpose, again, it depends upon how much you have to transport, fuel cost. So raw material cost for the capital investment for your storage system. Okay, so all this again comes around point 2 USD per kg for a centralized electrolysis. So the cost is like this, right? So around $4.3 per kg, around $0.2 per kg for transportation. So how much it ends up at the fueling station? If you go to the fueling station, currently the global rate is around $18 per kg. Okay, you have a transportation cost, other costs are included. So you have $18 per kg. Okay, so let me, this is for example, I put a Toyota Mirai, a Tesla, a sedan. Okay, this is a study case which I had taken. And if I fill the Toyota Mirai with 5.6 kg, I can go up to 650 kilometer. Okay, so 1 kg of hydrogen can take me 100 kilometer. Similarly, you can see a Tesla, 650 kilometer using 100 kilowatt hour. Okay, this is a sedan, uses a fuel. Okay, let me calculate. So distance traveled. Okay, so here it required for 15,000 kilometers by 150 kilogram of hydrogen. Okay, let us calculate. So you have a car in your home, right? So you just calculate per liter. Okay, here there is a, you just multiply this price with 150 kg with 18 rupees and 1400 liters with 80. So there will be a huge difference still. So what we see as an economy is we wanted this to be dropped as we develop the environment for production, for transportation, and for the end user application. So do you know, if you compare an fuel cell car with an electric car, the first thing you will ask about how long the battery comes in a electric car. So how many kilometers I can drive using without changing the battery. Let me say Tesla comes up with 2 lakh miles, and Toyota Mirai also comes up with 1,50,000 to 2 lakh miles. And we have to think about the replacement cost, right? So after that, so your efficiency goes down and you have to replace the fuel cell, and also here you have to replace the battery. Okay, that brings into another factor to drive this economy towards the future, the cost. How we are going to maintain the cost, how we are going to recycle, how we are going to replace the system. So these are all open-ended questions which still is under development process. So here it shows how much fuel is needed, and on the right hand side it talks about per dollar. So here if you see the last row, the Toyota Mirai hydrogen is $15, whereas all electric vehicle Tesla 50 kilowatt, 150 kilowatt is below $15 per kilometer. Okay, again it depends upon the country to country. What is your electricity cost? What is your hydrogen fuel cost? What is your capital cost of your vehicle? So everything matters. So life cycle cost is one of the area where you can at least figure out how much it costs, and you can calculate the life cycle right from the production of hydrogen to the usage of hydrogen. Okay, so we saw all these things. What are the challenges ahead for us? The challenges ahead are in 5 different baskets. So first, improve the cost effectiveness. Second, enhance the efficiency, achieve the scale of higher gigawatt production. Safety should be ensured dealing with hydrogen, and a proper and faster infrastructure for storage, transport, and grid. So each sector has to be developed in-house, indigenously, then the cost efficiency can be met. So these are the wide areas which we are looking into the challenges for hydrogen economy and fuel cell. Okay, so almost I am there, I think. So would you like to be part of a hydrogen economy? So now you might have an idea about the part of the hydrogen economy you will address. So there are different regions. I believe any students who wanted to pursue more research on this, you might have got an idea. Any startup people, any person wanted to start some work on hydrogen, I think it might have given you idea what are the applications people are looking into, what are the different types of fuel cells available, and what are the challenges and opportunities available. Hope I am a bit clear on it, or a lot of data to overwhelm. You can ask me or you can throw me your questions. Thank you, guys.
Yeah, that was really a very wonderful session on fuel cell technology, Prabhu. And also you had given a clear picture on its market potential. I'm sure the audience would have perceived different investment opportunity as well as application opportunities from today's session. So yes, of course, there are few questions like how do we establish a circular economy in hydrogen, and how do we bring down the cost by enabling mass production of hydrogen, and also like safety concerns like you mentioned about handling hydrogen storage and transportation and all. So of course these are open questions. Yes, we have our entire industry working on it, as well as we have our student force also working on this. A lot of PhD people, they can take inference from today's session and they can start any of such research activity. Yeah, thank you for such a wonderful question. And is there any solution on or better improvement of storing and utilizing hydrogen in a safer way for domestic usage, domestic market?
Yeah, so again, domestic market, if you see like people are using hydrogen for research purpose, like combustion, they are trying to use for research purpose. And again, the purity of hydrogen matters. It's normally 99.9% purity of hydrogen is required for the purpose. In terms of safety, uh, again, as I said, there are different way of transporting this hydrogen, right, from compressed gas, liquefied hydrogens, and the manufacturing of those containers, type 1, type 2, type 3, type 4 class. So again, affordability to buying those containers, storing that, and using effectively. Another thing, we have to be very sure. If I am using a hydrogen vehicle, a hydrogen container, I should be very careful and follow the instructions. So that is a big thing on us. So we need to be very careful when using the hydrogen. So even though the technology is available, we have to follow the things to make it safer.
Yeah, that's totally true. And there is a question from our audience. Is there any risk involved using hydrogen, like vehicle catching fire or blast, like how it happens in electric vehicle or IC engine vehicle? So how can we
Yeah.
comment on
So
that?
yeah. So that is unless you have a very compatible and a very safer system, it will be there will be no blast, because hydrogen evaporates very faster. So if you means it has a higher range. It will, if you open it, will if it is an open atmosphere, it will travel much faster. It will not be contained. Okay, so it's very less dense. So till now there's not much. There is no, I can say, like I don't know whether any incidents in the Toyota Mirai or something, but up to my knowledge there is no incidents happened with hydrogen fuel cell. So it is safer. That's what I already say. So we have to follow the safety procedures, having the tanks, all the valves. So regular checkups should be done, any leakages and all. So apart from that, it doesn't going to burst like EV. And EV also, that is a very wrong thing people talk about. EV is bursting and all. So again, that is a technical fault, engineering failure, I can say. People are not designing the product properly. That's engineering failure. If you do a proper engineering, nothing is going to fail.
That's totally true. That's most of the failures are because of the faulty battery packs or which is not qualified for production. So yeah, that's totally true, Prabhu. Thanks for bringing that up. And a few more questions also from Sudhir. Like any practical application of fuel cell in day-to-day life. You have given already a lot of examples. If you could reiterate a couple of examples, it would be great.
Yeah, so day-to-day life is, I talked about direct methanol fuel cells. So you can have, they will have the smaller fuel cell of a small capacity. Okay, if you don't want to use batteries, you can use the direct methanol fuel cells, which you will have cartridges of methanol. You can latch it in and you can derive the power out of it. So that is the one closer fuel cell which you can use it for your purpose. Currently, it is not developed in, I don't know, there is no product from India. So there is a product from German, there is one industry, so they are manufacturing DMFC, especially for the power banks and defense industries. So that is the only thing which I can relate. Other than that, MFCs are for higher capacities. So again, it depends upon the purpose you need and the cost also. So we also look into the cost, how much it costs for the purpose. Right?
Yeah, that's true. And will hydrogen fuel impact on the future of EV market? This is a question from Sumit.
Okay, yeah. As of now, no. So currently, there is no challenger for the EV market. Like hydrogen cannot be challenged because of the cost. We don't have the environment, so we don't have the right protection, larger protection environment, and the transportation. So once we have such a capability, then it can challenge. But what I see, the fuel cells first will come to the commercial segment rather than a passenger car segment. I see fuel cells will be more apt for transportation segment, commercial segments in India rather than a passenger car segment.
Yeah, that's a good. And also, like, yeah, we have a note from Manikandan sir. He is an enabler, one of the enablers of EV committee. I guess he might be connecting with you for prototype,
Okay.
a design prototype for H2 storage tanks. So that is something. Yeah, I just wanted to share with you. So if you are okay, yeah.
Yeah, fine, that's fine.
Yeah. And a question from CA Ramesh. What is the investment allocation by Government of India on research and production?
I don't have the numbers, but I can, if you connect with me, I can tell you the numbers. Currently, I don't remember the numbers.
Okay.
So government had, like a year before, I think, government had released a good amount of fund, especially for fuel cell DST projects. Government projects were released using DST. Funding was allocated for developing the fuel cells and all, but I don't remember the number exactly.
Yes. Manikandan sir, if available, would you like to ask directly? Yeah. And also, meanwhile, another question from Danny. What are the green effects associated with the hydrogen production? With batteries, we know in general about what happens, but what with hydrogen? What are the effects to the environment?
Yeah, as I said, we had distinguished the hydrogen production in different color categories. So if you are using renewable energy, then you can say is zero carbon because you are generating the energy to photovoltaic energy to produce hydrogen. for electrolysis process, and steam reforming. So steam reforming requires more energy. So those things, when you reform for the methane gas, you will have CO2 as a emission. So CO2 will be there. So it's about the what kind of a production strategy we are using. I think currently, if you wanted to do a green hydrogen, then you have to invest in your capitals, right? Your capital will go up with your solar plant, wind energy plant, and everything. So again, if it comes to the normal reforming, there will be emissions. To avoid that, we are moving into a blue hydrogen or a green hydrogen economy.
Understood. I think Manikandan sir, are you able to unmute now?
Yeah, thanks, Alex. Dr. Prabhu, thank you. Amazing insights. In fact, there's been quite a lot of reading that we do on fuel cells, but to get to hear from somebody who has worked on it and share some inside inputs, especially with respect to the whole life cycle, production, supply chain, and application. We have spoken only about production and application all these days, but my interest has always been on the supply chain and in the storage aspect of it. So that's one of the main reasons why I pushed across the question, because I come from the city of Coimbatore, where the engineering industry is actually very, very strong. Particularly the fabrication industry is getting very, very strong. So one of the areas of interest to us actually is hydrogen storage. People talk about extremely high requirements in terms of storage requirements. That's the reason why I asked that question. So if there is an opportunity to understand, I would like to see the possibility of making a couple of prototypes, take them up for testing, so that over the next 24 to 36 months, we are ready with the capability to manufacture these tanks when hydrogen is available as a fuel, be it for industry or probably for automotive solutions. So that's one area. Hydrogen side. That's it.
Yeah, sure. I mean, you can contact me. You can chat. We can work out with. We can work on the storage side. Yeah.
Perfect.
So I'm also from Coimbatore, so I know we had a lot of complicated things. So,
we'll touch base very quickly, sir.
Sure.
Yeah, thank you. So it was like a really wonderful session, Prabhu. I think we are done with the questions from the audience. If any other questions are there, people can put it on the chat window. Otherwise, like one more announcement is that it is not going to end with just one session of market insight and the potential investment opportunities. It is also like we are planning to conduct a series of sessions on fuel cell as well as the other eco-friendly technologies from automotive perspective. So I would request everybody to participate continuously for future sessions also. Yeah. If no other questions, yes, Prabhu, we can conclude, I believe. Yeah.
Yeah. Okay. Thank you very much. Thank you guys for posting questions and listening for our last 1 hour. Thank you very much.
Thank you so much, guys. I think we can wind up the session. Yeah. Thank you.